barium sulfate and sodium nitrate. Then when you talk about precipitation, this involves using an acid. If not an acid, you can use a soluble salt, like let's say a sulfate, a chloride, or a carbonate. Like let's say you take lead sulfate. You told to prepare lead sulfate starting with lead oxide. So what you're going to do is you're going to add excess lead oxide to dilute nitric 5 acid while stirring till no more can dissolve. Then you're going to filter the excess lead oxide and add a suitable sulfate, let's say sodium sulfate, to the filtrate to precipitate the insoluble lead sulfate. Then you're going to filter and wash the residue in distilled water and dry between filter papers. So if you want to obtain a pure salt, it's a must to rinse the salt if it's insoluble in distilled water, so that it can be pure. And also it's important to dry it between filter papers. Then if let's say when you are preparing soluble salt, you're going to get it in solution form, you have to dry it through saturating it. You can use saturation to remove the water of, okay, you don't remove the water of crystallization, you just heat it to a point where no more solid can dissolve at a given temperature. Yeah. Then now we're going to go to behavior of salts when exposed to the atmosphere. So we have this is where we're going to talk about deliquescent salts, hygroscopic salts, and efflorescent salts. So deliquescent salts are salts that absorb water from the atmosphere and dissolve to form solutions. Examples, we have common table salt and the one which we are talking about, iron 3 chloride. So the process, so when you asked about the process, you're going to say deliquescence. So deliquescence is the process by which deliquescent salts absorb water in the atmosphere and dissolve to form solutions. Then we have hygroscopic salts, to those who do geography, yeah. So we have hygroscopic salts are salts that absorb water in the atmosphere but do not dissolve to form solutions. Example, we have cobalt 2 chloride and copper 2 sulfate. Those ones that we learned in Form 1 in, was it temporary physical or chemical change, I'm not sure, but I'll check. Then so these ones are hygroscopic salts, and the process by which these salts absorb the water in the atmosphere but don't dissolve to form solutions is called hygroscopy. Then we have efflorescent salts, which are the water of crystallization when exposed to the atmosphere. Example, we have this one, it's iron sulfate with water of crystallization, and when you leave it out in the atmosphere, it will lose its water of crystallization to form iron sulfate, and the process is efflorescence. Effect of heat on salts. We're going to start with carbonates. So we have potassium and sodium carbonate. These ones don't decompose on heating, they'll still remain the same after you heat them. But other salts which are below them in the reactivity series, let's say like calcium, we have calcium carbonate, zinc carbonate, those ones, they'll decompose to form metal oxides and carbon 4 oxide. For example, here we have calcium carbonate. When you heat it, it will decompose to form calcium oxide and carbon 4 oxide. So we have another one. So the ones which are special and you have to memorize them are the ones for ammonia, because for ammonia usually different. So example, here we have ammonium carbonate, decomposes to form ammonia, carbon 4 oxide, and water. So here it's how this is how it's written: ammonium carbonate, it decomposes to form ammonia, carbon 4 oxide, and water. Then we have nitrates. We have potassium and sodium nitrate. They decompose to give out a metal nitrate and oxygen gas, the two of them, because they're very reactive. So they do not form nitrogen 4 oxide like the rest, so they'll just form a metal nitrate and oxygen gas. So here we have potassium nitrate, it decomposes to give potassium nitrite and oxygen gas. Then the rest will decompose to give a metal oxide, nitrogen 4 oxide, and oxygen gas. So we have example, we have lithium nitrate, it decomposes to form lithium oxide, nitrogen 4 oxide gas, and oxygen. Then we have the ones which are a bit different, like we have silver and mercury. So this one will decompose to form a metal, nitrogen 4 oxide, and oxygen. So let's say you have silver nitrate. Silver nitrate will decompose to form silver metal, nitrogen 4 oxide gas, and oxygen. Then we have ammonia. We said ammonium is always going to be different, and this reaction that you see here, we learned about it in nitrogen and its compounds. It's the reaction where you decompose ammonium nitrate to form nitrogen 1 oxide. So here's how it looks like. So when you decompose ammonium nitrate, it will form nitrogen 1 oxide and water. So the function of the cold water is to condense the water vapor into water, yeah, and the colorless gas is going to be, oh, it's not going to be oxygen like I've written, it's going to be nitrogen 1 oxide. Then let's go to effect of heat on chlorides. So metal chlorides, they don't decompose, they just melt on strong heating, most of them. So we have sodium chloride, which is solid. When you heat it, it's going to decompose to form aqueous sodium chloride. Then we have ammonium chloride. Ammonium chloride, it's going to decompose to form ammonia gas and hydrogen chloride gas. Chloride, it's usually the white fumes, like the way Mr. Maro did it, and he took ammonia and a gas jar containing ammonia and one containing hydrogen chloride gas, and he brought them close to each other and they formed white fumes. So this ammonium chloride here is the white fumes. Then we go to the effect of heat on sulfates. So sulfates of group 1 and group 2, which is alkali and alkaline earth metals, don't decompose on heating. But others, let's say like these ones, you just have to memorize them because they're not usually a lot. So we have sodium sulfate here. It will decompose to form N3 oxide, sulfur 4 oxide and sulfur 6 oxide gas. Then we have copper 2 sulfate. When you heat it, it will decompose to form copper 2 oxide and sulfur 6 oxide gas. Then after going through effect of heat on salts, the other thing that's important is here you have to know the reaction of sodium hydroxide with cations. So sodium oxide forms insoluble hydroxides with ions of magnesium, zinc, aluminium, iron 3 ions, copper 2 ions. They'll all decompose to form a precipitate. So in this reaction here, we have magnesium plus hydroxide ions to form a white precipitate or magnesium hydroxide. So when you just take zinc, aluminium, iron and copper, you're going to get a precipitate. So now for iron 2, iron 3 and copper 2, they're the ones that are going to be different. So let's say you take ammonia and then you react it in a solution which contains copper 2 ions, you'll get a green precipitate, which is iron 2 hydroxide. Then we have, if you take iron 3 ions and you react it with ammonia, or any other solution that contains hydroxyl ions, it will form a brown precipitate, which is iron 3 ions. Then we have the last one, which is copper 2 ions. It will react with any solution that has hydroxyl ions or ammonia to form a pale blue precipitate, which is copper 2 hydroxide. Then if you continue adding ammonia or any other solution that contains hydroxyl ions, you'll find it will form, I think, tetraamine copper 2. I don't know, it's a complex ion. It will form that complex ion, which is going to turn deep blue in color. So that's all about salts. Hope that helps someone. Now ninunulie zawadi because this took a lot of time. So yeah, peace out.
You can see it in my eyes, baby, I've been